Hello, everybody. My name's Robert Douglas, and this is Deploy Friday. It's a webcast from Platform.sh where we talk to cool people on the internet about cool topics. And today we have a special set of guests to talk about the Micronaut Java framework. So I'd really like to welcome Rodrigo Graciano.
Thank you. Thank you very much, Robert. It's a pleasure to be here.
Hold on, I've got to figure out where my echo is coming from. Sorry about that. Iván López and my colleague, Otavio Santana. So this is the latest in a series of broadcasts that we've done on Java-related technologies. We've talked about Quarkus, we've talked about Payara, we've talked about the Jakarta EE project and Spring Boot framework and a whole bunch of other things. So see our back issues if you want to explore those topics as well. The reason that we're talking about Java so much is because Java runs great on Platform.sh, and we want to explore all the aspects of that. So Rodrigo, why don't you start by introducing yourself a little bit, and then I'll go into Iván to introduce yourself, and then I'm going to hit you with the first hard question.
All right. Thank you. Thank you very much. First, thank you for the cool people. Very nice. Thank you. So my name is Rodrigo Graciano. I'm originally from Brazil. I'm living in New York for 10 years now. I work in a financial company in New York City, and I'm one of the leaders of the New York Java SIG. It's the first Java user group to be created. We will be 25 years in September. Very cool. So it's a pleasure to be here. Thank you.
Thank you. And Iván, how about yourself?
Hello, so I'm Iván López. I'm from Madrid, from Spain, and I'm a core developer on the Micronaut team at OCI. So basically, my work is working on the framework, and I also run the Madrid Groovy user group. It's a local group here about Groovy and the whole ecosystem. So anything related to Rails, Gradle, now Micronaut or Spock, anything related to basically Groovy. We have a lot of talks here, and we've been doing this. I've been running the group for almost 7 or 8 years now, and before that we did that for 2 or 3 more. So it's like 10, 11 years now, and that's all. Happy to be here.
Awesome. Now. Thank you so much, both of you. So, ready for my first hard-hitting question. Iván, can you describe to me and to the audience out there, what is Micronaut?
Okay, so Micronaut is a new JVM framework. It's not very, very new. I mean, we released 1.0, I think it was October 2018. So almost 2 years now, in a few months. And the idea behind Micronaut is to create a new framework from scratch with all the knowledge that, so the main creator, it's Graham Roche. You probably know him because he also created Grails a long time ago. Grails is built on top of a Spring and a Spring Boot. So with all the experience that Graham gained creating and evolving and maintaining Grails for all these years, so he decided to create Micronaut with basically to fix all the issues and all the problems that these frameworks have, which basically means Spring Boot, Microprofile, all those frameworks. What they do is computing and doing pretty much everything now at runtime. So when you start your Hello World application, it starts really, really fast because there is nothing there. But when you start having a real application with real code, the framework needs to read all your bytecode, all your classes, or your services, controllers, everything at runtime. And that takes time. And when you have more and more code, it takes more and more time to start your application, and it takes more memory because the framework needs to keep all that in memory to really know how your application behaves. So what Micronaut does is the same, but at compile time. Meaning that when you compile your Micronaut application, the framework creates a few classes, some kind of companion classes, with all that information that the framework needs to really know your application and to do the dependency injection and everything. So when you start your Micronaut application, the framework doesn't need to do pretty much anything because everything is already pre-computed ahead of time. So basically, with that, what you have is really, really low memory consumption because you don't need to catch anything in memory, and really, really fast start time. So you basically with not very modern, I have a 4-year-old laptop, I can start a Micronaut application in less than a second. And when you grow your application, it doesn't take too much time because of the same reason. Everything is compiled ahead of time. And one of the nice features about this is I'm pretty sure that all of you are aware of GraalVM. So when they announced some GraalVM a few months after we announced Micronaut, and it was pretty simple for us to make Micronaut work with GraalVM. We've been doing that since pre 1.0. So again, more than 2 years now, Micronaut is being compatible with GraalVM. And there are other frameworks that are not still there because it's complicated when you are doing a lot of runtime proxies, generating bytecode at runtime and all those kind of tricks. It's really, really complicated to make your framework work with GraalVM. They are close now, but it's complicated.
Before we go on, maybe in case there are audience members who don't know about GraalVM, Rodrigo, would you like to explain to us what that is and what its significance is in the Java world today?
Yeah, sure. So I think one of the biggest benefits on GraalVM became so popular is because you can compile native code. So your application will be smaller and will have only the necessary class of the JDK to run. So you don't need to carry everything.
So let's start with what it actually is. So GraalVM is a virtual machine by Oracle, and what's special about it?
Yes, correct.
Yeah, so it's like, so basically GraalVM is an umbrella project. There is a few things there. And the two important things for a JVM developer, one is the GraalVM JIT compiler. So instead of having the regular just-in-time compiler we've been using for years in the JDK, it's the same JDK version, OpenJDK, but with the GraalVM compiler, just-in-time, right? So it's exactly the same with another just-in-time compiler. That's what, for example, Twitter uses on production. The other approach I was referring, and also Rodrigo mentioned, it's the GraalVM native image, which is you convert your Java application into a native image binary for your operating system, Mac, Windows, and Linux. And with that, you don't have any dependency on the JVM at all. It's just a binary, the same as you compile with C, C++, or Go, something like that, a native binary. And with that, the application starts amazingly fast, and it consumes really, really low memory because it's just a binary and a small binary.
Every time I think about this, I'm always amazed that the internet has come full circle from back in the days when you used to write a CGI binary and deploy it on a web server. And now we're back to deploying binaries, whether you're running Go or Java or several other languages. Cool, thank you. So I had the hard-hitting question about what is Micronaut. I'm gonna hand it over to Otavio, who has the softer, easier questions to answer.
Okay. You mentioned about Micronauts because yes, that's an amazing tool, and you mentioned something about compile process. Is that related to ahead of time compiler? Something about that? And first, what is that? And second, why that is so amazing? It's so important to Micronaut.
Do you want me to answer that? Okay, so the ahead of time compilation means that when you compile your Micronaut application, the framework hooks into the Java compiler or the JVM compiler. Micronaut supports, so if you are a JVM developer, you can create your Micronaut application with Java, Groovy, and Kotlin. So it doesn't matter which of these three languages you are using. We have some kind of common API to hook into the different compilers. So for Java and Kotlin, we use the APT, the Standard Annotation Processor tool. And for Groovy, we use the AST transformations. That's how you hook into the compiler. So we have some code there that hook into the compiler. And in that code, we generate this additional bytecode that basically describe all your applications. So when you create a Micronaut application and you have a controller and you have a service and inject that service into the controller, we generate a few classes there to tell the framework that that is what you are doing, right? You have some kind of a special class that is a controller, and you expose on endpoint, and you inject, or do you want to inject and runtime a service? So all those classes are generated ahead of time during the compilation.
Okay. So I'm saying, instead of using reflection, that's a runtime analyzer, you are using some analyzing on the compile time, on the Java process, right? And that's why Micronaut is so fast to start up.
Yeah.
Is there any trade-off to do that, to go to this way? I mean, what can I lose if I use ahead of time compiler instead of reflection?
As you need, so when Micronaut compiles your application, it needs to generate these classes. So if you have really large number of classes, like a ton of them, compiling your application will take more time, right? Because we just not only compile or let the compiler compile your classes, we need to analyze those and generate some classes. But
how much time is a long time?
I mean, you need to have a lot of classes, so hundreds of thousands, right? It's not like if you have a project with, I don't know, 500 or 1,000 classes, it will take too much. It's not. You need to really have a really large project. And even in that case, now in Micro 2, we have done a lot of improvements. So for example, we now support Gradle incremental compiler. So the first time it will take, so basically the first time you compile your application, it will need to compile everything. But after that, when you modify only one class, it doesn't matter if it's a bin or a Pollo or whatever, we take advantage of that Gradle feature to only recompile all those classes without needing to recompile all the bins.
So it does like a, oh, sorry, it does like
a
diff. So it does like a diff on the bytecodes to compare the classes and only recompile whatever has changed.
I don't really know how that works under the hood. We take advantage of Gradle. So if you use Maven, so as the same, you can choose Gradle, Java, Kotlin, and Groovy. You can choose Maven or Gradle for your application. So if you choose Gradle, you can take advantage of that. If you use Maven, you can't. Basically because Maven doesn't support or that or yeah.
Okay, just to estimate, given I have a small project like that, it has 25 class, and I have a medium notebook with some 3 or 4 core processor and 6 GB of memory. How long gonna take to build my Micronaut application? I mean, don't need to be precise, but something around.
Nothing. I mean, there won't be a really overhead with that. It's the same as if you create a plain Java application without any framework probably and create all those 20, 50 classes and compile them. It's not that. Probably it's, I don't know, even less than a second of overhead, I mean, or probably less than that.
Oh, nice.
So it's not an overhead.
Okay. So, because when I read about Micronaut, the first thing that I saw was about serverless application. So Micronaut says it's a good framework if you decide to go to serverless, right? My question is, why, as a Java developer, should I use serverless on these days?
Don't you take that, Rodrigo?
I can see your mouth, but I can't hear you.
I think you're on mute.
Yeah. You're on mute.
I also noticed that too, Otavio, that the Micronaut website puts a lot of value on the serverless aspect of it. So I was wondering, is that a really differentiating technical distinction, or is it like a marketing decision? Are the majority of Micronaut developers actually writing serverless applications? Those were all questions I had when I saw that. And Rodrigo, you're still on mute. So maybe Iván, while he's figuring that out, you want to take the question?
Yeah. So I don't have the numbers between developers using Micronaut to develop or to deploy as a regular application of a serverless, but you can take advantage of the serverless because if you, the problem with the JVM when you deploy to something like AWS, Lambda, or other serverless platform, Google Cloud, Azure, whatever, is that it's the cold startup, right? The first time you need to bootstrap the JVM, it takes time. If you deploy your Lambda as a JavaScript application or Python, probably it bootstrap really, really fast. So it doesn't matter which framework or even if you are not using any framework, if you deploy to a serverless platform, you need to pay the price of the cold startup for the JVM. But what we do in Micronaut, we have two approaches. You can deploy as a regular JVM application. So we have a special support for serverless, as I said, the AWS, Azure, Cloud, Google Cloud, now Oracle Cloud. And we configure the application to only, we configure Micronaut to only start the minimum things that you need to do, right, to basically reduce that cold startup. The other approach that you can take, if you, for example, deploy to AWS, is that you can deploy a GraalVM native image, Micronaut serverless application compiled as a native image to AWS. So with that approach, you don't have that performance penalty or that cold startup penalty because there is no JVM application or JVM platform to bootstrap. So the application will start really, really fast. And answering Otavio's question about why, if I'm a JVM developer, I can deploy or I can take care of that for serverless, is because if you are a Java developer or a JVM developer and you want to go serverless, you probably don't want to write JavaScript, right, or Python. You want to continue using the same tools, the same language, the same framework. So with Micronaut, you can do that. You can create your application, continue using the same framework, the same tools, the same language that you want and you like, and deploy in another different way as a serverless. You also need to keep in mind that serverless is not for all kinds of applications and for everyone, right? If you have a long running process, you start an API and you have a lot of endpoints and something like that, maybe it's better to deploy the app as a regular application and it's good. But for some specific cases or things like, think about, for example, a job cron that you execute every time, once a day or every an hour, something like that. Maybe you can deploy that part of your application as a serverless app, and that makes sense. So you need to think how you can maybe split your application in different pieces if you want to deploy or take advantage of the serverless platform.
Okay, you hear me now? Perfect. Yeah, I just want to add on top of that because if you're going serverless, you'll be charged by how much you use for the time you are online. So if you can use an application framework like Micronaut, where your starting time is really small, and we had other frameworks that has the same characters. So it's a way of saving money, right? If your application takes 1 minute to boot, you're paying for this whole minute, right? So it's important to have one framework like Micronaut, so it has a lot of advantages and can save you money.
Yeah, and also the memory. For example, in AWS Lambda, you also pay for memory.
Correct.
So you can configure your Lambdas to use 128 megabytes of RAM or 1 gigabyte. But depending on what you choose, you pay more or less money.
Correct.
And also you mentioned about serverless and pay less money. Maybe I can use GraalVM to become native, right? What do you think about that approach? I mean, instead of start my whole JVM application, convert to native, and then put that on the serverless as a serverless application.
Yeah, I mentioned that before. If your use case fits into serverless, it's a good approach. For example, we launched 3 months ago or something like that, this web page, launch.micro.io, to basically bootstrap your application. You select the JDK version you want, the language, the build tool, and all the features, right? And you click on a button and download a skeleton of your application. So you don't even need to install our CLI to generate that bootstrap application for you. So what we did for that, the front end, the UI, it's a React application, but on the backend, we deploy we deploy one version of the backend for every Micronaut version, and that version is deployed as a GraalVM native image. Actually, I think now it runs on Google Cloud, but we have in the starter repository, we have examples for running that in AWS and also in Azure functions, and with Neti if you want to run it locally. So we have examples of everything, even if we are only deploying as in Google Cloud for production. And that's a really good use case because we expose a few endpoints on the API that the UI uses. And once you configure your application and click on the generate button, the UI sends a request to that Lambda, generates the zip file and download it. And that's all. And the process finishes. So that's a really good use case for serverless. And we decided to go with the GraalVM approach because it really fits the purpose. And as I said, it's really fast. You don't notice that you are running that. If you go to the web page and generate an application or play a little bit with the UI, you don't notice that you are interacting with a serverless app instead of a plain, Java application developed as in EC2 or something like that.
So where do I go to find the link to this service that you just talked about? Is it the first link on the Micronaut website, generate a project?
Give me 1 sec. Probably it's that.
Yeah, I think so. I'm going to put that into the
generate
chat
project
for people to go take a look if they're curious. And that actually leads me to another question as I'm looking at the Micronaut website. It says a modern JVM-based full stack framework. Now, what does that mean exactly? Because I have a concept in my mind of a full stack developer where, it has to do with everything on every level of the stack up through the browser and apps and the front end aspect. What does that have to do with Micronaut?
So it has to do that you can develop everything. So Micronaut is a framework instead of being a library. So for example, if you know Ratpack or Vertex or something like that, they are more toolkits or libraries, right? They are not very opinionated and they give you a lot of choices, but you need to wire everything for you. You can choose a lot of things, but you need to do it manually. Micronaut is a framework, so it's more opinionated, although you have a lot of options, right? But we kind of impose a few things. So we use this full stack framework because you can have everything if you want. You can talk to any backend. You can have databases, RabbitMQ, Kafka, queue supports. We have cron jobs. We can integrate with things like Consul, Eureka, all those kind of stuff. But you can also we can also provide a way to, if you want, we support templating technologies, views, so you can have your UI render basically going back as we did some years ago, rendering HTML on the server side now, right? Because nowadays it seems like you always need to create a backend API and some kind of UI using the latest JavaScript framework. But sometimes maybe you don't want to do that, or you can solve your problem basically rendering HTML, as I said, on the backend. So you can do that if you want. And we support TimeLeaf, handlebars, FreeMarker, and 4 or 5 different templating technologies. And you can also, if you want, we can serve any static file. So you can put all your JavaScript, HTML, and CSS, and deploy that in the same application, even if you are developing your application as a front end and a back end. You can put the front end files inside Micronaut and communicate to the same application. So you can have you can do anything you want basically.
Okay, nice. I have one question about that because usually you need to use database for sure, SQL database, I'm a Java developer I'm a Java developer who knows Spring and who knows JPA. How difficult is to learn the way that Micronaut use the database to integrate on my application? I mean, usually I have the add NT with add column from JPA, something like that. How
Yeah,
difficult is to I migrate my application to Micronaut?
zero difficult, zero code. We support JPA. We have Micronaut data. So we have two kind of flavors. We support JPA with Hibernate, and we support JDBC. So if you already have your application and you are using identity and column and one to many, many to one, everything, it's basically a matter of copying and pasting your code or on your classes to the new Micronaut application, and that's all. You can go to the launch web page, click on the features button and select data JPA, and it will generate the application with all the dependencies that you need, and that's all. The other approach we support is Micronaut JDBC, which is kind of low-level stuff. It's not like JPA. So depending on the use case you have, you can choose one or the other. With JDBC, it's like lightweight framework, so we have less overhead, and probably depending on your case, it will be faster, especially for read intensive applications. If your application is really write intensive, probably you should go with the Hibernate and JPA stuff. And one thing about this Micronaut data project is that it's built with the same features in mind as Micronaut itself. So there is no runtime proxies, there is no dynamic class loading, no runtime stuff, no nothing like that, right? No reflection. So one of the things we do with Micronaut data is that we pre-compute again ahead of time. We pre-compute all your queries. So when you create, you mentioned Spring Boot. If you know Spring data, you know that you can have an interface and the framework implements the interface for you, right? You inject that interface and you don't need to, you don't worry about that. You don't write the plain SQL. You just use find user by name, right? And the framework will translate that to the actual SQL query that will filter the users by name on the database. So we do the same. You can create an interface with the same rules, find user by name or find whatever. But the difference is that, again, the framework, when you compile your application, the framework pre-compute that interface, generate the implementation, and pre-compute the query. So the query is actually created in one of those companion classes. So when you run your application, the only thing that Microdata does is get that query, bind the values, and run it. That's all. The runtime layer is really, really thin, and it's really, really fast. And it also works really good with Graal VM, for example. We support for both JPA and JDBC. We support the main databases: Oracle, MySQL, Postgres, MariaDB, H2, Micronaut SQL Server. All of them with both regular plain JVM application and also with Graal VM approach.
And just go and if I'm not mistaken, Micronaut also has support for reactive database, right? I think MongoDB and Postgres are the ones I see before. I don't know if there's any other database.
Yeah, we have also support for reactive drivers for Postgres. I think also MySQL has a reactive driver through Vertex, some kind of Vertex subproject or something like that. And there is also support for MongoDB and Neo4j with the Bolt driver, which I think is also a reactive driver.
Okay, step back. My question is, what is Reactive Program? As a Java developer, why should I need to learn about that? And when should I use it?
Go ahead, Rodrigo. I'm talking too much.
That's fine. I think for reactive database we were discussing here, I think the biggest advantage, and this is the area that you're very specialist, Otavio. So if I'm saying something wrong, feel free to interrupt. I think the good thing about reactive, you're not your thread's not going to be locked. So your application your call to the database is going to be asynchronous. You're not going to be there waiting. Your Telegram is not going to be there waiting for a response. So you leave more computing power to your application, more trash to execute what they're supposed to, while the database did not respond.
Oops, yeah, I was in mute. Sorry for that. Okay, now I got it. Amazing. And one thing that I love on the Java world is the abstraction way. When you mention something like, okay, you can see using the interface, and I don't care about the implementation like Spring Data does to Micronauts, I start to cry because that is really, really amazing to Java developer in general, because I put an interface, find by something, and then I don't care anymore. That's something really amazing. But also, I'm talking about SQL database. How about the NoSQL one? Do I have something similar to, I don't know, MongoDB, Cassandra, something like that?
Inside of Micronaut data, we still only support SQL databases. So it's planned on the roadmap. We have plans to integrate MongoDB, Neo4j, and probably Cassandra or other key values and document databases inside Micronaut data. At this moment, it's not available yet. But if you use any of those databases, we have support for them. It's not as nice as using microdata with an interface and the framework implements for you, but we have support for them. You need to probably use the drivers directly, grab inside Micronaut behavior. So it's kind of, if you use any of those, Cassandra, Neo4j, Mongo, any of those databases, you can do that with Micronaut, but at this moment, not using directly Micronaut data. We will be there hopefully or eventually.
Good. Can I also make questions, or I can only answer them?
Go ahead.
Nice. I have a question because, as you were saying before, Iván, Graham Horosh, he created Grails and he created Micronaut, and recently he moved to Oracle, right?
Yeah.
How that is going to impact Micronaut?
Yeah. So yeah, if you know, if any of you or anyone that is not listening is now listening is not aware, yeah, Graham Roche joined Oracle on July 1st, so it's like 1 month now. I think it's good, but for the framework, because now, so we created, we announced 2 months ago or something like that, Micronaut Foundation, because we've seen at OCI that more companies are interested in supporting and in contributing to the framework. Not only you as a person that want to submit a PR, that's fine. We've been using that since very beginning. We have a real active community. We have a lot of, we get a lot of commitment, a lot of PRs from the community, and big things have been sometimes sent for members of the community. But sometimes as a company, you want to contribute in other ways, right? So it's not that simple. So with this Micronaut Foundation, we put in place things and legal things to be able to fund the framework and to contribute in different ways, and to also be able to some kind of have an opinion on the roadmap and things like that, right? So now, now that Graham is working at Oracle, another company also supports the framework, because even if Graham is working at Oracle, he's also working full time and it's committed to continue working on Micronauts, right? So it's not like he's doing any other thing. He's still there. But now there are two companies, OCI and now Oracle, with Graham, contributing to the framework. And now with the foundation, we have we've gathered more interest from other companies like, for example, Google, right? Some folks at Google are contributing with new features to support more stuff from Google Cloud. And now it will be easier for anyone or any company that want to contribute to the framework to do that via the foundation, if they want to support the framework in that way. So I think it's now Micronaut is in a better shape that it has been better or before, because we have the support for more bigger companies.
Yeah, I think.
But go ahead.
Oh, I think it's an interesting move that was done, and I don't know if that's not gonna cause a conflict between his contribution to Micronaut and Helidon, right? So Oracle has its own framework. Also, he's working closely to the Growl VM team at Oracle as well. So it's interesting to see how that's going to impact.
Yeah, we will see. We will need to wait basically to see how that will probably will work. I expect some kind of integration between Micronaut and Helidon in the future, in some kind of way, right?
Yes, exactly.
Okay, you mentioned Oracle, you mentioned Micronaut Foundation, but there is one more who is looking deeper on the Micronaut itself. That is the Java standards. Because right now there is huge discussion about CDI Lite. That's basically it. CDI. The whole idea is to does what Micronauts does every day, right? Instead of use reflections, start to use ahead of time compiler. My question is, what do you think about that? Do you think the future of the Java frameworks gonna be something that not use reflection anymore?
Yeah, I think that Micronaut started that. And so in the JVM, the Android folks have solved that in a long time ago, right? You cannot use reflection on an Android device because reflection is really, really cost. It has a lot of performance penalties. So you need to be clever and not use that, right? That's why you cannot use a big framework or not any, that's not the real word, but some kind of these frameworks on Android applications before, right? Because you cannot wait. If I tap on an application and I don't want to wait 10 seconds until the application starts up, right? Because it needs to bootstrap the whole framework, and that will load a lot of classes into memory and compute everything at runtime, right? So in Android, they've been using Dagger and tools like that for ages, using this approach of ahead of time compilation. So what Micronaut does or did, and it was right, the innovation was bringing that AOT to the server side, because for all those years the frameworks have been using reflection, and it's nice and it's amazing, right? There are a lot of really amazing frameworks on the JVM, but I think nowadays and in the future we will move to all the main frameworks and tools and libraries. We will move to pre-compute as much as they can ahead of time, instead of delaying to runtime because of this reflection performance penalty and all that stuff.
That actually brings up a question that I had right off, and that is if I have a older Java program and I go to run it on Micronaut, where's the line between what gets compiled in advance in terms of the reflection, and what does Micronaut have to still leave to reflection at runtime? What's the boundary? What can be precompiled and what can't?
There is no reflection at all, so and no runtime proxies and nothing like that, right?
So all of it's gone.
All of it is gone in the framework. I mean,
okay.
If Micronaut code itself does that, if you use, for example, as we discussed it before, if you are using a Micronaut application with Hibernate, you have reflection there, right? Because Hibernate uses reflection a lot, but that's not because of Micronaut. It's because this is how Hibernate works. So you cannot, unless you are only using Micronaut itself without any third-party dependency, you will probably use reflection and indirectly because of those libraries that you are using, right? But the framework itself doesn't use reflection. That's why, for example, you can use the dependency injection part. If you want, you can use it on Android, because it's a small layer and it doesn't use reflection. So you can use that. We support that. Probably we haven't put a lot of effort in doing talks or talking about that, how you can use micro dependency injection on Android, but you can, because of these techniques that don't use any kind of reflection at all.
So basically, when you try to compare, do you think there's no feature anymore to reflection? The whole scope is go through ahead of time compiler, right?
it's to have smarter compilers, or compile your, when you are a framework or a library, it's to be clever and smarter about how you compile those applications. Yeah, I think that's the
How much does that impact the programmer though? Like if I go write code, there are cases where I turn to reflection. Don't ask me to think of them, but I remember back in the day, I used to write reflection code. How do I navigate that? Should I avoid that? Is the framework going to take care of it for me and just ahead of time compile it away? Is there a way I need to annotate things? How do I think about this as a programmer?
I mean, you can always, nothing will stop you for creating a Micronaut application and do class for name and put some class into quotes. That will use reflection, and we don't do anything with that. If you are happy, or if you need to do that, that's okay. But I mean, depending on what you are doing, maybe for some cases there is no other approach like using reflection, or maybe that means you need to rewrite your whole library to avoid this using reflection, making or hooking into the compiler as Micronaut does. So depends on your use case. It's a matter of rewriting everything, which probably you cannot do that, or you don't want to do that, or you need to delay for a next major version, or you can only modify a few things and try to remove as much as reflection as you can.
Okay, but there are several unit tests, right, that use reflection anyway. Do you remove reflection from frameworks such as JUnit, something like that? Oh, that's okay. You just don't care about this part. That is
Yeah,
fine.
no. As I said, we don't. I mean, we don't do that. If you use a library that, like I said, Hibernate. If you use any kind of library that use reflection, you cannot, or we don't remove that. We don't do anything. We can. One thing that we don't do is modifying in any way user classes and user code. So if you compile your application, you have a Pollo and you compile that and you decompile, it's the same code. We don't modify the byte code. We don't do that. Nothing like that. That will be really intrusive into users code, right? So we don't do those kind of tricks. We generate companion classes, but we never modify your byte code. But if that library uses reflection or modifies your code or your byte code, it's up to the library, not up to Micronaut.
So I can use the Unity without any issue. That's fine, right?
Yep. Exactly.
Okay. So, is there any Micronaut tests beyond the Unity?
Is there what? Can you say that again, please?
In test framework such as JUnit to use?
Yeah, we do support JUnit 5, Spock, and Kotlin test. So if you go again to this launch webpage, you can select any combination of those, any language, any build tool, and any testing framework. You can mix and match, and you can do anything you want. I mean, if you want to create a Kotlin application, test it with Spock and writing and using Maven, you can. Or if you want to create a Groovy application and testing with Kotlin test and using Maven again, you can. Maybe a few cases doesn't make sense, right? For end users, I mean, probably not a lot of users will choose Groovy and JUnit and Kotlin test or something like that, but you can do. We support those cases, and if you want, you can. For us, Micronaut itself is written entirely in Java, except the integrations with Groovy or Kotlin. There are a few pieces in those languages. And for the test of the framework, we use Spock, which is based on Groovy. We love Spock a lot. For me, personally, it's way, way better than JUnit. Even with all the new features the team introduced in JUnit 5, I think nothing compares to Spock when testing JVM applications. And that's why we choose that for Micronaut. Even if all the core is in Java, we test in Groovy, and that's a nice approach. And we also use that, for example, when we do some kind of client work. We've been doing that. I've been working in a few projects in which we use Java for the production code, but for testing, we use Spock. It works really good. And for me, as I said, nothing compares to that. The tests are really, really readable, are really clean. You have a lot of features. You have all the power of Groovy for your tests. So it's a really, really nice combination.
If I may
Okay.
play the devil's advocate.
Sure.
Okay, so we know biggest Micronaut competitors, Quarkus, Spring Boot, I think the biggest one. And you know, Spring Boot should be the vast majority of the developers they should be using Spring Boot. If I'm not mistaken, Micronaut came before Quarkus, right?
Yes.
But last time I checked, I think it's very hard to measure market share, but last time I checked, there was more questions on Stack Overflow related to Quarkus than more stars on GitHub on Quarkus. And they have a very big company to back Quarkus as well, right? So how do you make Micronauts first-class player here? How do you gain market share? Why would a developer want to use Micronaut? If he can do ahead of time compilation, for example, you can do with Quarkus as well. You have this option to do native image. I think last Spring Boot 2.3 has added support to native images as well. On Quarkus, you can do it. So why would a developer, in your opinion, not use Spring Boot and Quarkus and go to Micronaut?
That is a great question, by the way.
Yeah.
Sorry.
Yeah, so you're right. So for example, I think Spring Boot doesn't provide yet out-of-the-box support for GraalVM. They've been working on that for a lot of time, and they have a lot of things that work with GraalVM, but I think it's not out of the box yet. I mean, you still need to configure a lot of things manually. I saw a blog post a few months ago from one of the core team working on that, and there is not, at least it's not at the level of Micronaut regarding to GraalVM. Because with Micronaut, you don't need to do anything. It's YATS. So go again to the launch web page, select the GraalVM feature, and you're done. And if you see, there is only a couple of dependencies. You don't need to do anything else. Another thing you mentioned is, so both Spring Boot and Quarkus have really big and large companies behind the frameworks. So OCI we are something like probably less than 200 people in the whole company, and they are really big companies. They are on the stock exchange and some things like that. So now we have with the foundation, we have the support of very big companies like Oracle, right? And we will have the support of more companies. So it will be easier now to, if you haven't yet heard about Micronaut, now it will be easier to hear because of this support of the foundation and other companies. And answering your question, why if I am a JVM developer, should I try, right? It's because basically, talking about the Spring Boot, they have been doing a lot of improvements in the latest versions, basically because of Micronaut and Quarkus. But even with all those improvements, they are still based on reflection. They cannot change that. That's doing this, right? It's a big framework. They've been developing Spring, I think, for more than 15 years, things like that, or maybe even more. So if I don't know their roadmap, but if they have in mind to keep or to remove all the reflection, which again, I don't know if they have or not, that can take time. So even with all the improvements that they've done, the behavior of the apps is not the same. They still pay the performance penalty. They load classes into memory, and they use runtime and all that stuff. And regarding
Are there benchmarks? Are there benchmarks around that? So right now, you're basically saying, "Hey, we're faster," because that's an implementation detail in the background, right? Like, I mean, in the end, I don't really care what the machine's doing in the background as long as it runs and it's fast. So how much faster?
Yeah, so we've seen a lot of benchmarks done for different people, and those benchmarks, for example, use old versions of Micronaut, or they didn't configure the application properly, or they didn't compare apples to apples, right? So Graham created a webinar 2 or 3 months ago, something like that, comparing, it's a live webinar without any cuts, any editing. He created the same kind of Hello World application with an endpoint and things like that with the 3 frameworks, and he tried to compare apples to apples. So it's I can share you later the link if you want to put on the show notes and things like that. It's on the OCI webpage, so you can, if you Google for RAM, object computing, Quarkus, Spring Boot, and Micronaut benchmark, it will be there. So you can see, and there is a repository there with the code, so you can try for yourself. And also a month and a half ago, Jason Schindler, which is on our team, create another benchmark, again on the 3 frameworks with updated versions and with the code there. So you can clone the repository, run everything on your laptop, and check that yourself.
What were the results?
Yeah.
So who came out in front?
It was Micronaut in pretty much all of them. I think regarding memory consumption, we are still a few megabytes behind. I mean, we spent a few more megabytes of RAM compared with Quarkus, but not too much. And the worst was in pretty much all cases Spring Boot, if I recall correctly. So there are 2 benchmarks that we publish, which doesn't mean they are the best, or you know, they are may biased because of we publish that. But as I said, there is the repository there, so you can clone and you can run everything on your laptop and check that we are not lying, right? And if we are doing something wrong, one of the things we've seen with those public benchmarks is that maybe we did something not good, configure Quarkus or Spring Boot, and we get a few pull requests from something from their community saying you should check this or configure this in this way because whatever reasons, right? So we've been trying to keep all those benchmarks up to date.
So I have a couple of questions now for Otavio. So Otavio, what does it take to run Quarkus on Platform.sh?
Oh, that's so easy, so fast. That's why we decided to write several articles to integrate Quarkus with Platform.sh, and the link is here. So we have 4 articles to first hello world with Micronauts, and then how integrate Platform.sh with SQL database. Micronaut with NoSQL database, again, that was MongoDB. In the last one, how can we integrate with microservice? And one thing that I love on the Micronaut is because it follows the whole 12-factor application. That means I can override any kind of a configuration that I want to. And that's amazing because Platform.sh follows that good practice as well. What does that mean for me as a Java developer? I can put the whole configuration on repository to run locally. Something like localhost, the password, something like 1, 2, 3, 4, 5, 6, something that's amazing. But
I
just
hope everybody's
locally.
writing that down. That's literally Otavio's password.
Yes, don't do that, please. And when I move to the clouds, my whole point is I don't care about the user. I don't care about the password. And I can integrate that easily between Platform.sh and Micronauts. And that was really, really amazing. And beyond that, the articles itself, we have one click button where with just one click, you can deploy your Micronaut application at Platform.sh, easily using Java 11.
So that's an example application that you've prepared, Otavio. What does that application do, and what can people learn by studying that?
How can you create a Micronaut application, a simple hello world to microservice, then Micronaut with SQL database, I guess PostgreSQL. But as Ivan said, it's a JPA. The whole point is if it lets you change between PostgreSQL with MariaDB or something like that, I just need to change the driver. And that is it on my side. I wrote one that a feature that I love so much in Micronauts, that is Micronaut data, because I used to be a Spring Data developer and I love Spring Data. When I could see that I can use just one interface and don't care about the implementation, that was something that I almost crying, because that's amazing. I mean, okay, fine by name, so I don't care. Micronauts, do it to me because I don't care.
I get the impression
And
that Java makes you cry a lot, but in the good sense.
yeah,
It's tears of
sometimes.
happiness.
and and also for sure, uh, Micronauts, microservices with MongoDB. And why not reactive? Because I'm a hipster. And today is Friday. Why not put some NoSQL with reactive program? So yes, we have the whole link here, and you can see the article plus the code, where with just one click button, you can deploy your application in the cloud with Platform.sh and Micronaut.
That's very nice. Platform.sh supports multi-cloud deployments, hybrid.
So when you create a Platform.sh project, you choose the cloud region that's managed by us, and that spans a different number of different cloud providers, but you basically pick the geographical region that you're interested in. We don't have a native deployment mechanism that will put it in multi-clouds or multi-regions, but you could set that up yourself by deploying multiple projects and then worrying about the data synchronization requirements that you have. So in a way, yes, in a way, no, not multi-region, definitely multi-cloud. We currently work with AWS, Azure, GCP, OVH, and other clouds on the way.
And one thing that I love as Java developer at Platform.sh, that is, I don't need to put independence on my code. I just need to put three files. One to define my application, and that has the name, the Java version, the Java version, how I build and how I execute. Another one is about my service, where I just put my database or any kind of service that I need, such as Postgre, MariaDB, MySQL, MongoDB, something like that. And the last one is about route. As Java developer, that is amazing because I don't need to handle something about the infrastructure anymore. I put the infrastructure as a code as approach on my code, push on my repository, such as GitHub, GitLab, Bitbucket, and so on, and it's done. And that's amazing to start up.
Sounds amazing.
Cool.
Amazing.
Very nice.
It is amazing. So
And
we're coming up to
if
the
you have
close.
any kind of application, you can migrate easily to Platform.sh, and also move your application to Java 8 with Java 11 with change just one line. And if
It's
you are a
true.
Java developer, you know how hard it is to move your application Java 8 to 11. And Platform.sh, go to the application file, set a type to Java 11, and deploy application. And guess what?
It's so
Welcome
true.
Java 11. Yeah.
All right, well, we're coming up to the top of the hour. Before we wrap up, I want to give our guests, Rodrigo and Ivan, both the chance to promote something that you guys are excited about coming up. So, Rodrigo, you go first. Do you have anything that you'd like to announce to the audience, like a user group or a conference or what? Go ahead.
Yeah, sure. So, as I said, I'm part of New York Java SIG. Is the largest North America user group. It's the first user group ever created. We'll be celebrating 25 years in September. We're gonna do some very special event. So please follow the NY Java SIG on the social media. It's NY Java SIG on Twitter. Events are free. Everybody's welcome to participate. We have hands-on workshops as well. There's a lot of cool stuff. If you want to follow me, here's my website, Graciano Dev. I publish articles once in a while, suggestions of articles to read over the weekend to keep up to date with everything. And my Twitter handle is here, is open. Feel free to follow, ask
Where am
questions
I?
and everything. I got used to this.
I feel naked. I don't have anything here.
Yeah,
Okay,
see my
if you want to
web.
follow me, there is some clothes behind me. So if you'd like some,
That's everything that my web design skills allow me to do. That's pretty much that. It's a pleasure to be here. Thank you for having me.
Great, thank you. And let's make sure and get those links into the chat and into the description so people can follow them. Iván, what are you promoting?
Well, I'm not sure. We are going to give, now that we cannot travel to go to conferences or to anywhere, actually, we are going to do a lot of webinars and live talks on remote talks and different user groups and conferences. We've been doing that. So I think today probably already passed. I don't know. We were doing, or maybe we have already done a webinar about with Guillaume Laforge, which is the it's a Google Cloud developer advocate about how to deploy Micronaut applications to the different Google Cloud staff. And we have been doing a lot of them, and we will do more in a few months, in the next month. We will be talking different user groups and different conferences. So follow us on Twitter at Micronaut FW framework if you want to learn more about where you can learn more about Micronaut. And I think that's all. Thank you very much for having me today. It was really, really nice.
A pleasure, and it was a great discussion. So let's wrap it up with that. We'll update the description with any links that are missing. This recording will be available forever. So thank you for joining us, and great luck with everything. Bye, everybody.
Thank you. Bye-bye.
All right, the live stream has ended.